Hello students, today we will learn about projectile motion. We are studying about motion in a plane, motion in two-dimensional plane. Now, what is a projectile? Let me take for example this piece of chalk piece, right? A piece of chalk I have taken. Now, I take this chalk and drop it like this. Now you see the chalk is falling vertically down. So what is attracting towards ground? That is gravitational force or acceleration due to gravity. Gravity is pulling it downwards. Fine. That is vertical motion. Now I take another piece of chalk and what I am going to do, I am going to throw it like this. Now I see that I have thrown this body like this. And this is in horizontal motion. This is in horizontal motion and this was in vertical motion. But does it continue in the horizontal motion like this? No, it does not continue. It naturally takes a path like this, a curved path, and it falls on the ground like this. Now, when we study deeply about this, any body which is under the influence of two forces, right? One is vertical force, another is horizontal force. Two types of motions are involved. That is called a projectile. For example, you take a bullet or take a football, anything which is moving, which is under the influence of two forces. One is the gravitational force, another is the force which you give, right? And in such cases, they are referred to as projectile. Now, when I take this body and come to a point here, let us say, let me dissect it at this point now. Anyway, the gravitational force G is acting, anyway it is acting, that is the vertical force, and there is a force we have given here. See, we have thrown this body, and once we throw the body, we lose control of the motion of the body. We are totally lost control of the body. Only we gave the velocity to it. That's all. After that, we cannot do anything with the velocity. So, horizontal velocity U, let us say, is remaining constant. Horizontal velocity, once you set it, and that will remain same. But vertical motion again is influenced by the acceleration due to gravity. So, let me come to the point here. At this point, this velocity which is acting U, which is in the horizontal motion, right? We don't know the exact value. I will only say U x component. It is in the x direction. If we take the x-axis like this is U x component. And here, as it is coming, the velocity here, it is V y, which is the vertical component. This is V y. In reality, how the body is going, it is tracing a path like this. This is the final velocity. It is the resultant velocity under the influence of x component, y component. Let us say call it as V. Watch carefully here. This is the resultant value, the final velocity. At this point, what we are talking about is at this point. Now, let me take it carefully, let me dissect it more carefully. Look here, this is the vertical component, Vy, and that is the horizontal component. I bring it to the base here, Vx, and how is the final resultant which is acting like this? This is V. Fine. Now, this is 90 degree. What we have is a right angle triangle, and this is 90 degree. And this angle is angle theta. Okay, this is the angle with which we are subtending. At this point you take, and this angle which you are going to throw, this angle any point of time, and that angle is theta. Okay, so when this is theta, if this is the angle is theta, and this is opposite, equally vertical opposite angle, so this is also will be equal to theta. So I have taken this as theta. So now what is Vx and Vy? We will take now what is defined sine theta. Sine theta is vertical component or perpendicular upon hypotenuse, Vy upon V. Or simply we can say Vy is equal to V sine theta. So we know the vertical component, right? Let me write here Vy is equal to V3. I can write it here itself. Vy is equal to V sine theta. So my work is done here. Now I come to the horizontal component. What do? Define cos theta. What is cos theta? That is base upon hypotenuse. What is the base? Vx divided by hypotenuse is V. So we can say Vx is equal to V cos theta. Okay, you understand these concepts which I have done here, right? Let me erase one by one all the things now, right? And I know that in the horizontal direction, when it is traveling the distance, the component is Vx, which is V cos theta. So this is called resolution of vectors, which we learned in the previous videos about how do we resolve a vector. Why should we do that? Why should we learn a mathematical concept? Because in physics we are applying that. I hope you understand. Now, one thing we should be very clear. When we talk about the body, you should know that when I throw this body horizontally, the horizontal motion and the vertical motion, they are independent of each other. They are totally independent of each other. That means horizontal motion does not affect that means the velocity which I supplied does not have influence on the vertical motion. So these two are independently studied. One is horizontal motion and another is vertical motion. These two are independent of each other and we study on that. Now I am going to take a simple example for you and then explain it how that is actually going to happen. Okay. See, let me again take, let us say there is a tower. We have got a tower. From the height of the tower, let us say is h. From the top of the tower, we are going to throw a ball. We are going to push it like this with a velocity u, let us say, initial velocity. Now, let me draw the ground surface. When I push it like this, the body will go like this and it will come and fall down. Right? Now, it is traveling a horizontal distance, right? Which is in which direction? X direction. That is called range. What is it called? Range. Range is the horizontal distance traveled by the projectile. From what height we have thrown it? From height h. Now, we will take the basic equations of motion and study this motion. First, let me take the horizontal motion. Let us say we know velocity is equal to displacement upon time, or displacement is equal to velocity into time. That is equal to, which is responsible for it to move in this direction? That is the horizontal component. Everywhere the horizontal component, it was pushing it and brought it till this point. Fine. So that is horizontal component. We just now did that. Horizontal component is u cos theta. So I will write here the displacement is range, which is called range. That is velocity in the x direction multiplied by time, which is equal to u, we have taken u cos theta into t. This is horizontal range. Here also we have taken ux, so u cos theta. Either you take v or u, it doesn't matter because we are talking about only one velocity here. So this is the horizontal motion we are talking about. Horizontal motion. Right. Now, what about the vertical motion now? Now we come to the vertical motion. Vertical motion, it is traveling a height h. That's fine. It is traveling a height h. So it is coming down like this. Now, what is the initial velocity? Very carefully noted. It is very important in the conceptually. Horizontally I have thrown. What is the initial velocity vertically? 0. I am not pushing the body. I am not throwing the body. I have only given the horizontal motion to it. And here I am just dropping it. So initially, vertically, the motion, the velocity was 0. Are you clear about it? The starting point, the initial velocity, don't worry, mix up with this, right? Vertical motion, the velocity, initial velocity is 0. But it will come and strike here with a particular velocity, that is final velocity. Now we go to the second equation of motion, S is equal to ut plus half at square. But for the height, vertical motion, h is equal to ut plus half gt square, where g is acceleration due to gravity, which is 9.8 meter per second square or 10 meter per second square. But very carefully watch, what about this velocity? Initial velocity, but that initial velocity here in the y direction has turned to be 0. So naturally this term will get cancelled, it will become 0. So you have h is equal to half gt square, and this is how you calculate the vertical motion. So the vertical motion, the h can be calculated simply by half gt square. This is the formula. And the range can be calculated using u cos theta multiplied by t, and this is what is going to be in the x component. This has a very important implication. That is, suppose if I do an experiment here, like I am shooting a video. So let me say this is the point here. Suppose if I take a body like this and drop this body, okay, and I take another body, yeah, it is dropping by itself, right, and let me take the body here and I drop it, and I take another body here, okay. Now what I am going to do, I am going to simultaneously drop it and flick it. I flick it and drop it. Let us see what's happening. You see, you may not be able to watch that. You will find that both of them will reach at the same time. Both of them will reach at the same time. How? You see, watch carefully here. Why should it reach at the same time? Because t square, which I am giving, is equal to 2h upon g, or t is equal to under root 2 upon g, 2h upon g. Okay, so what will happen? H is remaining constant, g is remaining constant. So we said that horizontal motion is independent of vertical motion. So naturally both of them will come and strike the ground at the same time, because it depends only on the height. It does not worry about the range where you are throwing. It does not matter that. Okay, that depends on the initial velocity. It depends on the initial velocity. If suppose I take it and throw it with 20 km per hour, or I throw it with 60 km per hour, then the range will change, but not the height, because we have fixed the height as a constant. Okay, with this we will move to the next concept of projectile motion. Here I have taken a height, but we will also can shoot it from a lower point here, from the ground. That we will do in the next video. Thank you so much.